this, geospatial parameters, to change the initial sea level rise. In the first week of class, we talked about solving the partial differential equations. We needed an initial condition and a boundary condition. As of now, we have been using initial condition as 0. The water is sitting at still water level. If it's mean sea level rise, the mean sea level that you have as a datum, NAVD88, whatever it is, the water is at 0. And it's sitting there. We can, however, change that. And we can say, you know what? We believe there's a sea level rise of 0.5 meter by the time this storm is going to hit. So we can raise the sea level to 0.5 and rerun the storm. What do I have? Oh, I have a bunch of statistics. You guys can look at that. Now, why do we care? We care because things will change if the water goes up. So your initial condition, in reality, I mean, if you have a bathtub, who cares if it's 0.5 up or down? The result is the same. But on your study area, it might not be the same. So if you think about, I have a bunch of definitions here. Let me work you. The first box here, we're just talking about what is sea level rise, which I think it's pretty obvious to this crowd, which is if we had a mean sea level on A, we would have a surge on top of it. What happens is on B, we have now a new mean sea level, and we have a surge now on top of that mean sea level. If you think of changes that we could possibly have is, as the water goes up, your vegetation might migrate. Your vegetation will certainly change because it's going to get drawn underwater. You can't breathe, whatever you say that in English. And, you know, your dune might go away. That's exactly what Lorena was saying, but that's the sea level rise thing. So your initial condition is like, might drastically change. Therefore, your fetch now that was contained within a little back lagoon or something, it's now much greater. So you can have much more wind now transmitted to the water than you had before. Yes?
So the only way to add sea level in the model is to add the value in the initial condition?
No, you can add it afterwards. Okay. If you add it afterwards, you're neglecting all of this. If you're adding afterwards, you're doing that A thing. You know, you calculate your surge as is, you get your surging A, and then you add 0.5 to it. That's the easy way. If you incorporated it before, you're now taking into account all the changes that that given sea level rise might have in your landscape before the model. So we did a bunch of testing. And here you can see how sea level rise would change the landscape just by using a bathtub approach, which means you go to GIS and you raise the water and you inundate things. And you can see how a landscape like the Barrier Island becomes almost inexistent in several places here. That's before the surge, before the hurricane even comes in. So then we can run the hurricane here and we can run the hurricane here, and we can compare the surge. And that's what we call the surge anomaly due to sea level rise. I have a plot here. That's what I was going to show. And now I'll go back to the other slides. And we have quantified that for this study area, the surge anomaly went up, you can call it significantly or not, depending on whatever you think it's significantly. But for 0.5, you only went up 0.1 meters, so you can just call it the same. You know what, we don't care. We just add the sea level rise after. For a lot of sea level rise, that story begins to change. So this is the surge anomaly, which means the difference between the surge before and after the sea level rise. So on top of the surge you had already, you're getting this on top of it. So sea level rise is not only increasing the water level at first, it's also increasing the water level as the result of the surge. Because for this area, it's changing your landscape. Now it could go either way. So this is very localized. So that's why it's important to rise your sea level first and then see what you get. Because it might not always increase.
Also?
Yes.
So you said in many of these questions you didn't find any difference between the approach of before and after?
Yes. I'm saying both.
For example, you got difference on other.
Yes. Yes, that's what I'm saying. And then you can also think about is, how do you change your landscape with sea level rise? Not straightforward. You know, how do the ecosystem migrate? How do people respond? And that's a question for the agent-based modeling. You know, how does the house market respond to sea level rise? Are we moving away, or are we still there? So, you know, where is the development going, and where are the ecosystems going? There's a group that works with ecosystem modeling, and there's a project by NOAA called the Marsh Migration, that you can get predictions of marsh migration with sea level rise. So that will give you a new land cover data set to run your 13 under sea level rise. So you could do that, for example. So, and this for our study area, this is how bottom friction changed because of marsh migration in our study area. So that's an example of how you could be approaching this. I'm cruising through these slides too quickly. On top here, it's the wetlands area affected by sea level rise. Here's how my bottom friction changed because of sea level rise. And here's how the windshield changed because of sea level rise. And then the last plot I had was the summary of things, of how storm surge on average increased because of sea level rise.
So the effect is not linear, right?
No, not at all. That's the thing. That's the take-home message. So if you're working for FEMA or with FEMA and things like that, and you have the FEMA map as of today, and you want to add 0.5 meter of sea level rise for future condition, you just add to that, you should be really careful. Okay, so far we covered then water level offset. That parameter in ANSARC is called the sea surface height above geoid, which is where you can regulate the water level, your starting water level. We've been using 0 and you don't even know. It was on your 15. Now I'm giving you a chance to change that, if you want. There are other parameters on your 13. Some of them we will use it, some of them we will not. Bridge billings, frictional parameters, if you're ever doing bridge work, you might want to read into that. I'm not going to get into detail. I think that's going to overwhelm you. My goal was to go through the ones we did. I just wanted to show you guys there's 6 more. Some of it, the bottom reference land D0B, it's for 3D modeling. We're definitely not going there. So there's some that you won't ever use it. Tau 0 helps with stability a lot. So that, we should generate that. The start dry, surface submergent state, you can use that to set a cell to start dry, even if it's below your starting elevation. So let's say you're saying 0 as your still water level. Any mesh node that's below 0, it's considered wet at the start of the simulation because it's below 0 by default. But if you're in an area, let's say like Louisiana, where inland you have some negative slopes, but it has no connection to the surge, you might want to say, you know what, I want those to be dry at start. Because even though they're below 0, the surge never got there yet. You can do that with this parameter.
Which was start dry?
Yeah. Yeah. And when we get to waves, and if we want to do wave refraction spatially, we can talk about that. We're not going to go there yet.